that the answers were x equals 0 and x equals 1. X equals 0 and x equals 1. Bruno, you got that?
Yeah.
Bruno, can you walk us through it as a class?
Sure.
Thanks.
Okay, so first you gotta simplify the equation.
Mm-hmm.
You subtract 7 from both sides.
Okay.
And that equals 0.
Yep.
And you subtract the 2x.
Yep.
Which is gonna go to the other side, so it's gonna equal 16x. The second minus 16x. And then you put it equals 0.
Good.
And then you have to do like the greatest common
Factor. Mm-hmm.
and which is going to equal 16x. And then inside the thingy is going to be x. And then minus 1.
Mm-hmm.
And then you got a 16x equals 0. Then you gotta subtract or divide 16 from both sides, which is equals 0. So x equals 0.
Mm-hmm.
And then the other one is x equals 1.
Yep, so x equals 1. Okay, so you guys, one thing that I really want you guys to focus on is one side of the equation, it doesn't matter which one, needs to be 0 in order to use the zero product property, okay? So do you see how Bruno subtracted 2x and 7 from the right side to give me 0 on the right? That's what you're supposed to do. But then you have to factor them. You can't just say 16x squared equals 0 and 16x equals 0 because these are not being multiplied by each other. Do you guys see that? It's the zero product property, right? So it needs to be two things multiplied by each other. So that's why we took out the 16x so we could set each of those equal to 0. Any questions? No? All right, then let's get started. Okay, so when we hear the word factor, okay, we normally just think about pulling out a monomial, right? A single term. So I want you guys to write this down. Write down 4x squared plus 4x. And if I said to factor this with the greatest common factor, what would you guys pull out from each of the terms? Brandon? 4x, right? So you'd get 4x times x plus 1. Agreed? Now, factoring in this lesson is going to be a little bit different, okay? When we're factoring in this lesson, we are going to be given x squared plus b, which will represent a number, times x plus c. Go ahead and highlight that, okay? Now, we are going to factor, this is now going to be a trinomial. We're going to factor a trinomial, and a trinomial factors into a binomial times another binomial, right? Because you guys remember when we were foiling two binomials, we would get a trinomial most of the time, okay? So now we're doing the reverse. We're starting with the trinomial. We have to come up with both of the binomials that form that trinomial. And there's actually a really easy way to do it, okay? But I just want to walk you through, that is what we're doing today. So I want you to draw a little arrow. We are going to change this into x plus blank times x plus blank. We're going to get two binomials that when you multiply them together, they give you that trinomial, okay? So it's essentially the opposite of foiling. All right, so how do we do it? Well, there's 3 steps, and I wrote them out for you over here on the right, okay? The first step that you're going to do is identify your A term, your B term, and your C term, okay? So go ahead and look at the first example, okay? Your A will always be whatever's next to x squared. Your B will always be whatever's next to x, and your C will always be the term that has no variable, right? So just the number. What form is this expression in? Standard form, okay? Make sure all of your expressions are in standard form before you start to factor. Got it? Okay, now there's no number underneath A. What's technically there that we don't see? A 1, right? So put a 1 there. Okay, so A is equal to 1, B is equal to 10, and C is equal to 16. You guys with me so far? All right, so A, B, C. Now, for all intensive purposes, A in all of our examples that we do today will always be equal to 1. Okay, so I want you to highlight that. For all of the examples in 7.5, A will be equal to 1. So this is a process that you only use when A is equal to 1. When A is equal to something else, we will learn that later, okay? But I need you to be writing down A equals 1 so you know that this is the process for that. Cool beans? All right. Now, second step is we need to write out the factor operations. And what that means is, okay, two numbers, we're going to put blanks for them. We'll add together to give me B. So their sum will be B, and their product will be C. Okay? In our instance, what was B?
10.
What was C?
16.
So we need two numbers. They're going to be the same numbers for both, right? Two numbers that when you add them, they give you 10, but when you multiply them, they give you 16. Does anyone know what two numbers would fit in there?
2 and 8.
2 and 8, okay? So what's 2 plus 8?
10.
And what's 2 times 8?
16.
So 2 plus 8 equals 10, and 2 times 8 equals 16. So watch. This expression, x squared plus 10x plus 16, factors into x plus 2 and x plus 8. Okay? The 2 is coming from this factor, and the 8 is coming from this factor. Now, since this is the opposite of foiling, right? What do you think would happen if we foiled this? Where we started. Yeah, we would get the original. Very good, Bryson. So, you do not have to factor, or you do not have to foil afterwards, right? But we're going to do it for this example just so I can show you that you can always go back and check to make sure that you factored it the right way, okay? So let's go ahead and foil this out, okay? X plus 8 and x plus 2. I want you to write it down again. X plus 2 times x plus 8. You guys with me? How would we foil this? Someone walk me through it. Shayla, go for it.
You do x times x.
Good.
Which gives you x squared.
Yep.
Then you do x times 8, which gives you 8x.
Uh-huh.
Then 2 times x, which gives you 2x.
Good.
2 times 8, which gives you 16.
Good.
And then you add this, the 8 and the 2.
Yep.
So you get x squared plus 10x plus 16.
Wow, that was beautiful. Very nice. You guys, does that match what we started with? Booyah. Is that not cool? Okay, now this method will work as long as A is always equal to what? 1, okay? So you should not see a number in front of your x squared, right? Because A is technically, when we write it next to a variable, it becomes invisible, right? What's up?
I missed the lesson. Can you just give me a quick thing on how to foil?
No. Okay, all right, so B, we've got x squared plus 7x plus 6. So what we're going to do here is first things first, identify A, B, and C. So A, B, and C. And I know, guys, this sounds really, really repetitive, right? To do this every single time. But it's super important for the later lessons that we write this down, okay? So what's A here? 1. What's B? 7. And C is 6, okay? So let's go ahead and write it down. We need two numbers that when you add them, they give you B. What's B in this case? 7. And two numbers that when you multiply them, they give you C. What's C in this case? 6. Can you come up with the two factors that satisfy these two equations?
1 and 6.
1 and 6. Because 1 plus 6 gives you what?
7.
And 1 times 6 gives you
6.
6. So my final answer is going to be, when I factor it out, it's going to be x plus 1 times what? Yeah, times x plus 6.
And then
What's that?
we foil.
No, so foiling is only if you want to check it. Right now, this is our final answer, right? Now, if you were taking like a quiz or a test and you go back and you foil it, that's just to check to make sure that you factored it correctly. You want to try some on your own? All right, do C and D on your own. Go. All right, so let's check it out, guys. In C, okay? What's A?
1.
What's B?
9.
And what's C?
8.
Okay, so A equals 1, B equals 9, and C equals 8. We can use the method that we're using because A equals 1, right? If A equals anything else, we're going to use a different method, okay? So always check that first. So A equals 1, B equals 9, C equals 8. Two numbers need to add together to give me what? 9. And when we multiply them, they give me? 8. Let me show you a little trick, okay? If you're having trouble coming up with the numbers, okay, I want you to highlight the C term. Do this on your page. Highlight the C term and write out all the factors of that number, okay? So, factors mean two numbers that multiply together to give you 8. What are some of them? 8 and 1. What else? 4 and 2. Anything else? I think that's it, right? Okay. So, now only one of these will work, right? Which ones, when we add them together, give us 9? 8 and 1. So you know those are going to be your 2. So we're going to put 8 plus 1 equals 9, and 8 times 1 gives me 8. Do you see how writing out the factors gives you less choices? So now you're like, oh, I know it has to be 8 and 1. Because what's 4 plus 2? 6, right? Does that match the 9? No, so you know you're not going to pick that one. Does that make sense, guys? It's very helpful to write out those factors, okay? So what my final answer is not 8 and 1, though. What is it?
X plus 1. And then X plus 8.
Good. X plus 1 times X plus 8. Guys, it does not matter the order you write these binomials in, okay? You could have also written X plus 8 times X plus 1. Are we Gucci? All right, Brandon, what's up?
If the B term is always one number higher than the C term, is it always going to be the C term times 1?
Very good. So, Brandon, notice if the B term is always by a multiple of 1, like a difference of 1 between your C term, yes, one of your multiples will be 1. Okay? The same thing happens in D, right? 11 is one number higher than 10. So we know that it's going to be 1 times whatever it is. Okay? So A in this case is 1. B in this case is 11. C is 10. So we've got blank plus blank equals 11. And blank times blank equals 10. The two numbers you should have picked are 1 and 10. 1 and 10. And you should have gotten x plus 10 times x plus 1. We feeling okay so far? It doesn't get that much harder. All right. So the next few examples that we're going to see are when B is negative and C is positive. Before we jump into them, okay, I want you to highlight that statement. When B is negative and C is positive. And I want you to write a little note, okay? So we've got a number plus a number is going to equal a negative number, a minus, okay? And then we've also got a number times a number is going to give us a positive. What do we know about the signs of these two factors? When two numbers are added together, they give us a negative. But when you multiply them, they give you a positive. Daniel?
It's a negative number because a negative times a negative equals a positive.
You're saying one of them has to be negative?
Both of them have to be negative because
Very good.
Yeah, a negative plus a negative is practically just a negative subtracting.
Very good. They both have to be negative. Because in order for two negatives to get multiplied together to give you a positive, right? They both have to be negative, right? If one was negative and one was positive, what would our C have to be? Negative, right?
Yeah.
So, but it's positive, okay? So in this case, you know both of your factors have to be negative. Cool? And I want you to write that down. Both factors need to be negative. Are we all okay with how I got that logic? That logic there. We're Gucci? All right. So let's do the first one, okay? We've got x squared minus 8x plus 12. What do I do first, peeps? A, B, C, baby. Every single time. A, B, and C. What's A here? 1. What's B?
8.
Not 8. Negative 8. And what's C? 12. What do I do next?
You write down blank plus blank equals negative 8 and blank times blank equals 12.
Good.
And the two numbers are
Hold on. I want to pretend, like if you got it, I'm super happy for you. Let's pretend like we're having trouble with this one and we cannot figure out what numbers go there, okay? Highlight the 12. Oops, not that 12, the other 12, this one down here. And let's write out all the factors of 12. What are numbers that multiply together to give me 12? Let's list them all. Brandon? 6 times 2. What else?
3 times 1.
3 times 1. What?
I said 4.
Oh, 4. Yes. Brandon? 12 times 1. Is there anything else? I believe that's it. So these are the only 3 options we have, right? And now we know they both have to be negative, right? Because we established that in the beginning. B is negative and C is positive. So they both have to be negative. Which ones fit the bill? That when they're added together, they give you -8, but when you multiply them, they give you +12. Brandon? -6 and -2. Because what's -6 plus -2? -8. And what's -6 times -2? +12. So my answer is what, guys?
X minus 6 times X minus 2.
Good. X minus 6 times X minus 2. How could we check if we did it right? Foil this sucker, okay? Yeah.
Does it have to go in that order?
No. You could put X minus 2 times X minus 6. Good question. Any other questions on the first one? All right, B's pretty easy. I'll let you guys do that one on your own. But let's go down to D, okay? I want to do D together, and then I'll let you do B and C. All right, what do I do first? Primero. A, B, C, baby. Every single time. I know it's tedious, but you got to write it down. A equals? B equals? -14. And C equals? 24. We're on D, guys. We're on D. Letter D, okay? All right. What do I do next? Blank plus blank equals? -14. Blank times blank equals? 24. Does anyone know the factors that go here? Dougie?
12 and 2, or -12 and -2.
-12 and -2. Very good. -12 plus -2 gives me -14. And -12 times -2 gives me +24. So my final answer, Adam?
Is x minus 12 and x minus 2.
Good. We Gucci? Yes. All right, B and C are all yours. Go for it. All right, for B, you should have gotten W minus 1 times W minus 3. Are we Gucci there? Any questions? No. Ask if you have a question. We're good? All right. For C, did we get N minus 7 times N minus 5?
Yes.
Let's go. Yeah, Brandon?
I put X minus 7, so it's okay.
No. Do not put X. Why would you put X? It's an N here, right? No, that is a common theme that happens on the homework, guys. Make sure when you're entering your homework answers, you put the variable that they're using. Because I saw some people, they're like, I'm putting X minus 7 and X minus 5, and I'm getting the wrong answer. It's because they're using N here. You guys got it? Okay. Any questions on B or C? Yeah, Brandon?
On the test, you can change the variables.
No. You do not change the variables.
No, on the test, are you going to change them in the question?
I'm going to use whatever variable I want. All right. Moving on. Okay, our last few examples are when C is negative. B is going to be positive. B is going to be negative. But when C is negative, this is what happens. Okay? Highlight that. This is what happens when C is negative. That would mean a number times a number equals a negative. A number times a number equals a negative. What do we know about our factors? Brandon?
One's positive, one's negative.
One has to be positive, one has to be negative. Yes.
Can I do A?
Yeah, go for it.
Okay. So A, you have to label them A, B, C.
Mm-hmm.
A is equal to 1, B is equal to +4, and C is
Yep.
So it's going to be -7 plus, wait, no. -3 plus 7. Positive 7.
Okay.
And then, yeah, and then -3 times 7 is going to give you 20, -21.
Yep.
So it's going to be x minus 3 times x plus 7.
Excellent, Janessa. Excellent. Okay. Now, the reason that we have a positive factor and a negative factor is because this C term is negative. Do you guys see that? Now, one more hint for you guys. If B is positive, right? The larger factor needs to be positive. Do you guys see why? Because when you add them together, right, it's going to say positive, right? So the bigger number needs to be positive. If B was negative, which number would need to be negative? The bigger number, right? So if this was -4, the bigger number, which is 7, would need to be negative. Do you guys see the difference there? Okay. Let's do one more together and then I'll set you loose. Yeah, what's up?
Oh, wait, hang on, let's together.
All right, B. Who wants to try B? Brandon, go for it.
So A is 1, B is 2, C is -15.
Yep.
And then it would be x minus 3 times x plus 5.
X. Whoa. Hold on, you're jumping a bunch of steps. Blank plus blank equals 2, and blank times blank equals -15, right? What were your factors?
-3 plus 5, then -3 times 5, and then it would be x minus 3 times x plus 5.
Good. X minus 3 times x plus 5. Okay, another way to help you is you could have taken this -15, find all the factors, which would have been 3 times 5, 15 times 1. I believe those are the only two, okay? And you know it's not going to be 15 and 1 because their difference has to be 2, right? And the difference between 5 and 3 is 2. And you make the 5 positive because your B is positive. Okay? All right, go ahead and try C and D. Go. All right, the answers are on the board. Check them. And then discuss with your neighbors. Go. Okay, guys, so in the first one, okay, B was equal to 13, C was equal to -30. You should have come up with your factors being 15 and -2. Guys, this one was a little bit confusing because a lot of people picked 3 and 10, right? Because 3 times 10 gives you 30, and 3 plus 10 gives you 13. But remember, guys, one of them has to be negative, right? And one of them has to be positive. 10 minus 3 will give you +7. So you couldn't use 10 and 3 as your factors, okay? All right, and then D. Your factors were -7 and 6 because together they add to give you -1, and -7 times 6 gives you -42. Okay? Questions? All right. You guys, this last one, it's going to intimidate a lot of you, okay? But bear with me, okay? Bear with me. This would be like a challenge question on one of your quizzes or tests, okay? All right, so let's check it out. A farmer plants a rectangular pumpkin patch in the northeast corner of the square plot of land, okay? So they're talking about this little patch right here. Go ahead and box it in. This is our pumpkin patch over here in the corner, okay? The area of the pumpkin patch is 600 square meters. So throw a big 600 in the middle of this stuff. Put a big 600, okay? We know that the area of that little rectangle in there, the pumpkin patch, is 600, okay? And it says, what is the area of the square plot of land? What is the area of the entire thing, okay? What is the area of the entire thing? Now, right off the bat, okay, we know, how do we find the area of a rectangle? It's length times width, right? So in this case, what's the length of the entire box? Guys, the entire square. What's the length of the entire square?
60.
It's not 60.
Oh,
It's S. It's S meters, okay? So our length is going to be S. And we're going to multiply that by the width. What's the width here, guys? S. So it'll be S times S. What is S times S? s to the second power. Okay? So, but we can't figure out the area unless we know what s is. Do you guys agree? Yeah. So, in order to solve for s, we have to use the fact that this little piece is 600. Okay? Now, I'm going to show you something. Please try to follow along as best you can. Okay? I'm going to explain it like two different ways, and let me see if you guys can get it. Do you guys agree that this whole length is s meters? And this length right here is 30. How would we figure out, let's go ahead and draw this in red. How would we figure out this side using the s and using the 30? You don't add them. Isa?
Okay, so what number, like s is like the number that multiplies by 30?
Not quite. Brandon? Nope.
Find the factor of 600.
Hold on. So let's say, okay, this whole thing is s, right? What if we were to take away this piece? What if we were to take away the 30? What would we be left with? The region that we want, right? So couldn't we represent this side as s minus 30? Okay, I'll say that one more time. Do you agree that this whole length is s? But we want to take away this region so we get what this is, right? So it would just be s, the whole thing, minus this piece, which is 30. So s minus 30. Now let's do it to the other one, okay? This one right here. Do you guys see that one? So the whole side is what? S, right? But we're going to take away 40. So that will be given this little piece right here. Do you guys see that? So this piece is going to be s minus 40. Bruno, what's up?
Couldn't you just add a 30 to the beginning of just half of it?
Done what?
Couldn't you just...
No, because we don't know it's half. We don't know it's at half.
I mean, it kind of shows you that's half of the length.
Wait.
Oh.
Mr.
So add 30 above it and then... you add
No.
that-
No. Yeah, what's up?
Do you think you can find the square root of 600 and then just add that length?
No, because it's not a square, right? These are going to be different lengths. The rectangle is going to be different lengths. Okay, so we know that the area of the pumpkin patch is 600, right? And we know that this side is s minus 30, and this side is s minus 40. How do we figure out the area of a rectangle? Length times width, right? So, do you agree that the length is s minus 30, and the width is s minus 40? So, s minus 30 times s minus 40 should be equal to what? 600. Right? Because it told us the area of the pumpkin patch was what? 600. And the area is this side times this side. You guys with me? I know this is a challenging one, but just follow along, okay? So, what would we do from here? Foil it. Yeah. So foil. What's s times s?
So s times s is s to the second.
S to the second. What's s times negative 40?
Negative 40s.
Negative 40s. What's negative 30 times s?
Negative 30s.
And what's negative 30 times negative 40?
1200.
1200. Or 1,000 plus 1,000, 200. Equals 600. Okay? Now, remember, we want to use the zero product property. So what should we do so we can use the zero product property here? Subtract 600 from both sides. We should also combine like terms. What terms are going to get combined, guys? The 40s and the 30s, okay? So those two are going to combine. We should get negative 70s, right? So s squared minus 70s, and then this is now going to be plus 600, right? Equals 0. I did 2 steps there. Are we all okay with what I did here?
Yeah.
I just combined this negative 40s and this negative 30s, okay? Now, do you guys remember right? When we were doing zero product property, we would factor something out. But now we have a trinomial. But can we still factor it with what we just learned today?
Yeah.
Yeah, so let's factor it, okay? So I want you to write A, I want you to write B, and I want you to write C. Right? So A is equal to 1. B is equal to what?
-70.
Negative 70. What's C equal to?
600.
600. So we need two numbers that when you add them, they give you negative 70. And when you multiply them, they give you 600. Brandon?
Negative 60 and 10.
Negative 60 and 10? Not quite.
Oh, wait.
Daniel?
-10 and 60.
Very good. Oh,
Wait,
not quite.
no. 60 and 10. Wait.
Negative.
Negative 60
and negative.
and negative 10, okay? They both have to be negative. Why are they both negative here, guys? Because C is positive, right? C is positive, but B is negative. So they both have to be negative, all right? So now I'm going to rewrite this as S, hold on. S minus 60 times what?
X minus 10.
S minus 10 equals 0.
S.
Now, do you guys remember when we have two things multiplied together and they're set equal to 0, what do? We just factored. You set each of them equal to 0. So we're going to say S minus 60 equals 0. And we're going to say S minus 10 equals 0. How do I solve these? Add 60, add 10, add 60, add 10. You're going to get S equals 60 and S equals 10. Take a second, let it soak in. Let it sink in for a sec. It's a long one, okay? All right, now, I want us to look at the pumpkin patch. One of these values is not going to make sense to use, okay? And I want you to think about the pumpkin patch lengths. They were S minus 30 and S minus 40, right? Which one of these values, S equals 60 or S equals 10, doesn't make sense to use in our problem? Rocco?
S equals 10.
Why? You're right.
Because the top one, we already know it's over 40.
Yeah, exactly. So do you see how the length of S, the whole thing, right, is 40 plus some value? If S was 10, right, then you're saying that this 10 has to be bigger than the 40. Is 10 bigger than 40? No. Also, if you plugged in S here and S was 10, could you have the length of one of your sides of a rectangle be negative 20? Because if you plugged in 10, you would get 10 minus 30, right? Which would give you negative 20. So 10 does not make sense. So we're going to cross out 10 as an answer. And we're only going to use S equals 60, right? So if the side of each side of the square is 60, right? How would we find the area of the entire square?
60 times 60.
It's just S squared.
That's 600.
So it would be 60 times 60, or 60 squared, which is 3,600 meters squared. You guys, this was a challenge one, okay? Let it sink in. We'll try more of these. We'll get better at them, okay? But I need you to turn in these notes and then get started on your homework.